All right, what's up to anyone who's on right now? So welcome to week 3. And just going to wait for the chat to get going here so we know what to work on. But once again, hello and thank you for stopping by. Oh, hello, Psycho Slate. Yeah, my evening's going well. Hello, Ricky, Tommy, Psycho Slayer. Oh, to Ricky, yeah. So, Ricky, I guess you might be taking Calc 3 right now. So, I don't know. What math are you taking? Oh, hello, Max. How you doing? Hi, Dory. How you doing? So, as usual, any topics that you want me to cover, within the scope of, the stuff I said I would cover, I'm more than happy to help with. So, oh, you were registered for Calc 3. Okay. Yeah, it's definitely it's a fun class, but it's a little bit tricky. Let me just see something. Maybe if I flip, just experimenting. This looks more, yeah, I think that's better. Okay, makes me look like I'm a lefty, even though I'm not. Oh, nice. So you're 5 on BC. Now you don't have to take any more math classes. Good for you. That's a accomplishment you'll take with you forever. Okay, minoring in CS. So what's your official major again? What's your title of your major? I forgot if you were going the business route or finance or something. But to anyone else that's here, remember, more than... Oh, Xiaolong, hello. Good to have you here. Anyone else, that has any specific questions, whether, any level of math, I'm happy to help. Assuming, of course, it's not prove Fermat's last theorem, something that I can't do. Oh, finance major. Very nice. Data science. Excellent. That's a good, whoops, wrong screen here. I'm just getting the materials ready. So let me just get this out of the way. All right, back to the stuff here. I'm going to just freeze this temporarily. I'm going to just get the behind the scenes set up here. That was all right. Oh, there we go. All right, now we're back in business. Okay. The starred questions do not have to be done just yet. Later in the year, I'll say yes, but for now, we didn't learn enough stuff yet. Oh, Imagine, hello. Nice to see people here. So, but yeah, if you have any questions from the packet, any specific topics to anyone who's maybe not necessarily in calculus, I'm happy to help. So I was just rummaging around for the packets of fun. So let me see here. I scroll up. Let me pick a year. I mean, this will definitely have it. Yeah, Ricky, the packets are fun. They're still going strong. Oh, and anyone to the chat who has me this year, Ricky is one of last year's, from last year's class. So, it's nice having the old crew here as well, hanging out with the new crew. So yeah, anyone in the chat, feel free to type in a topic. I could get talking about math. I'm happy to. Let me just. Here it is. Oh, thank you. 18.1. Did I guess I hit 18.1 thousand. Nice. Yeah, it's the channel's growing, but once again, I thank you to all of you because especially the people here right now in the live stream, you're contributing to the growth of the channel. Anytime there's a big crowd, the YouTube algorithm likes that, and then they start recommending it to more people to click and join. So I'm grateful that you're all here supporting this. What's this? Oh yeah, it's trending upwards. So anyone have a packet question or something of that sort? And I keep pressing the wrong buttons here. All right, and I just X'd out the whole screen. So let me just multiplying matrices without any variables or anything. Oh, very nice. I haven't done that in years, but let's all right, so 29 is also requested. So Psycho Slayer, let's see. From what I remember about a matrix, I believe that you could only multiply matrices that if it's like a 2 by 3, you can multiply that by like a 3 by 1. It's like a 2 by 3 matrix could multiply with like a 3 by 1 matrix. From what I remember. So let me think of one. If I had like 1, 2, -2, and like 0, 4, 1. So if it was something like this, let me just 2 by 3. I want to say something like this you could do. It's been quite a while since I've done linear algebra. So I'm glad you're bringing this up because it's like fun to recap this. Although this is something in pre-calc they might start adding in. But let's see. Let's say it's like 1, -1, 2. Something like this works. And there's like a hand gesture that's done when you do this. But the key was that when you multiply a matrix like this, I remember that it results in like a 2 by 1 matrix. Something of this sort. I'd have to double check this because I'm, once again, very rusty. I took linear algebra in like 2009 or 2008. So it's been like, 14 years. Yeah, the dot product. Oh, so Kenny, you could tell me, is this accurate here? If you do a 2 by 3 multiplied by like a 3 by 1, it results in like a 2 by 1. Tell me if I'm like on point here. If you're taking linear algebra, I think you learned that in like the first week. But I'm rusty here. So I'm glad that we have someone taking linear algebra right now. So Kenny, hello. So this one here, I believe the process, you're doing like 1 times 1. So you're doing like 1 times 1. So it's like 1 times 1 plus, and then you're doing 2 times -1 plus -2 times 2. And that's like the top entry. And then you'd have, in the next row, we change colors here. So let's say we go like this. We'd have 0 times 1. So 0 times 1 plus, and then we'd have 4 times -1 plus, and then we have 1 times 2. All right, so this is like the technique that I'm remembering. And this, we'd have 1 minus 2 minus 4. So 1 minus 2 minus 4. So that gives you -1 minus 4 is -5. And this is 0 minus 4 and plus 2, which will give you -2. So I believe this is the way to go. All right. But once again, I said like from pre-algebra to calculus 2, technically this falls outside, but from my instincts, I remember like the visualization of this using the dot product, this be the way to go. Oh, all right. Does that make sense though? So at Psycho Slayer, did that make sense, this whole process here? Like how to... Yeah, but one of the key details that I still remember is that when you're multiplying a matrix, like these numbers have to match. It doesn't matter that like 2 and 1 don't match. Like a 2 by 3 could multiply with a 3 by 1. Okay, and I believe, yeah, it's like the first number tells you how many rows and the second number tells you how many columns. Cool. All right, so you'll have a head start. And so Xiaolong, you said question 29. So let's scroll there. And I'm just going to open up some of the other stuff I'll need. So I'm going to minimize this for a second. The display. And, okay. I'm going to pull the answer key here too, just in case, you know, to make sure that we're on point here. So question 29, and now let's get this GoodNotes back open. All right. So here it is. Question 29, let me just jot down, is we have x squared plus y squared equals 25. So right away I'm thinking, so this is, yeah, question 29. This is a circle. So make that a little neater. A circle of radius 5. Okay, so a circle of radius 5. And what we're looking at here is we want to find the second derivative. So they're asking you at 0, 5, which is up here. They're asking you d squared y over dx squared. So this is at 0, 5 equals, and that's what we want to know. So to find the second derivative here, well, for one, we should find the first derivative, and we're going to have 2x plus, and the derivative of y squared is 2y dy dx, and the derivative of 25 is 0. All right, so that's first order of business, is if we want to find the second derivative at that point, we should first find the first derivative. So now subtract 2x, you have 2y dy dx equals minus 2x. And then if you divide both sides by 2y, so we'll make a little space. So divide by 2y. And the 2's cancel, 2y goes. And that gives us dy dx equals negative x over y. Let me make that a little bit neater. I don't know what happened there. All right, so negative x over y. But now, this is where it gets a little interesting. To find the second derivative, we're going to use the quotient rule, which, remember this formula on the side, the quotient rule is this here. Okay, there's your quotient rule. So here we have the low function, so we have y times the derivative of x is negative 1, minus, so we have low derivative of the high function minus the high function times the derivative of the low function, which is dy dx, and then we're dividing by y squared. Now, one thing you can do here is, once again, we want to evaluate this at 0, 5, is you could calculate what is the derivative at 0, 5, the first derivative. And this, if you plug in x is 0, y is 5, that's going to give you 0. Or, if you know how to draw this, you see how the slope here, the slope at 0, 5 is 0. See, we have a slope of 0 there because that's a horizontal line, a horizontal tangent at this point of the circle. So what happens is now at this step when we plug in, we're going to have the second derivative at the point 0, 5 equals, and now we have y is 5 times negative 1, and then we're going to have plus x is 0. So even with this, x is 0 and the derivative is 0 over y squared is giving us 5 squared. So this is giving us negative 5 over 25, which is negative 1/5. So question 29 is looking like choice D, and it is. All right, cool. Did that make sense? I'm hoping, yeah, that was like not so bad to follow. Oh, and Bilal, hello. I'm saying hi to you a little bit late, so hi and thanks for joining. All right, so that's, yep, question 29. Are there others? I'm just reading the chat here. Do you have a video on trig substitution? Oh, trig substitution. I believe I may have a video on that. I have to look. Let me see. Trig substitution. I mean, I could I could come up with an example here. I have to go looking for one. Maybe the AP Calc Problems book has it. So hang on a sec. I'm going to flip this off for a moment to open that AP Calc Problems book. And then maybe I could find a nice trig substitution. I think what I have to start doing is getting the questions ahead of time. Because when I'm solving them on the spot, like, I mean, for the most part, like, if it's something I remember, like, I'm confident, like, I'll get us there. But it's going to go way smoother if I could, you know, like, see these questions ahead of time. All right. So I will flip this back on. And let me scroll here. But I'm just going to do control find and write the phrase trig. See if they have a trig substitution. Oh, okay. Here's, I want to say something like this. All right, let's hope for the best here. So question 12. So Bilal, how about, you're talking about integration, right? Because I believe like trig substitution is usually a technique for this. So is that ringing a bell? I'm hoping that's something that looks familiar. All right. So here, the trick to these, and I'm basing this off of, I haven't done one like this in a while, is we look at this identity. And right away, I'm looking at this. Did I get a 120 on the Putnam? No, sadly, I'm not. I didn't even take the Putnam. But that's the perfect score, right? Now, the smartest person, I'll talk about one of my professor's kids. It was a math prodigy. If you look up this name, Aaron Pixton, I would just Google this name. This guy is like legitimately like one of the smartest people like who went to Binghamton. He went to Binghamton when he was like 13 years old. His dad was a professor there, and I had his dad as a professor, but this kid like was taking graduate level math when he was like 13 or 14 and just like destroying like everything. This guy, he wound up getting his PhD from like, I don't know, like Princeton or something like that. Super, super smart. But he was what's called a Putnam Fellow for getting a perfect score on the Putnam exam. Like he was like a top ranking guy. He was also like a US junior chess champion. He's like a child like chess prodigy as well. Like very, very smart. So I'm glad you brought up the Putnam exam because it's a like interesting piece. But Bilal, to your topic, this here, you know, I forget off the top of my head, but when I look at this, my instinct is to do like divide by cosine squared. This is just to give you some helpful trig identities. And you have tangent squared theta plus 1 equals secant squared theta. All right, so my first instinct here is to say x equals, and I'm going to make x equal 3 tangent theta. And if x is equal to 3 tangent theta, this means x over 3 equals tangent theta. So if we draw a right triangle on the side, here's theta. Opposite of theta is x. The hypotenuse is 3. And then this would be square root of x squared plus, and then we would have 9 like this. So just Pythagorean theorem. All right, and now what we have from here is we could say that dx equals 3 secant squared theta d theta. So all of this is going to be important because now we transform this integral and we're going to have the integral of 3 times dx, and dx is 3 secant squared theta d theta. And now in the denominator here, we have radical 1 plus 9. And if x is 3 tangent theta, then we're going to have, oh, all right, you know what? I already see I have to make an adjustment here. So because I haven't done this in 100 years, you kind of catch your mistake on the spot. What I need to happen is I need 9 to cancel out here. So you see how if I make x equal 3 tangent theta, the problem with that is it's not going to cancel this out. So I have to adjust this a little bit. And I apologize if this is going to throw you off. But let me just see here. Yeah, x I want to be 1/3 tangent theta. And so that's going to adjust this a little bit. Let's just chop out this part, which is probably going to chop this part too. So I'm going to make this 1/3 tangent theta. Because the goal is we have dx equals 1/3 secant squared theta d theta, which then means if we draw this into a triangle, that means 3x equals tangent theta. Okay, this is going to work out better. Okay, so we have theta is here. Tangent is opposite over adjacent, so this would be 3x, this would be 1. So then tangent of theta is 3x over 1. And then this would be 1 plus 9x squared. Okay, so now it's going to work out nice. Sorry about that little mix up there. So now I have dx equals 1/3 secant squared theta d theta. So I have 3 times dx is 1/3 secant squared theta d theta. And now I have 1 plus 9, and then notice if x equals this, x squared is 1/9 tangent squared. So I'd have times 1/9 tangent squared theta. Here like this. That's our x squared term. But now 9 times 1 over 9 cancels. And now this integral, 3 times the third cancels, becomes the integral of secant squared theta d theta over, and notice what we have left. We have square root of 1 plus tangent squared. But what do we say? 1 plus tangent squared equals secant squared. So now we have the square root of secant squared theta, which is now secant squared theta d theta on top over secant theta on bottom. And now secant theta cancels, and this just becomes secant theta. And this is not the nicest integral. I believe that this one is like natural log absolute value secant plus tangent. I have to, there's like a little side proof of that. So this one, there's like side quest. So good question, Bilal. There's a tricky topic. They used to cover this in BC, but then they took it out because it made too many people depressed. But if you're taking the integral of secant x, the trick is actually to multiply the top and bottom by secant plus tangent. Like this is the proof of why that formula works. And then this is the integral of secant squared x plus secant x tangent x over secant x plus tangent x. And then this is actually like a u sub situation. You would just say u equals secant plus tangent x, and then du would be secant x tan x plus secant squared x, and then dx. Okay, so this is where you get that integral from. It's like du on top over u. So it's natural log absolute value u plus c, and u is equal to secant x plus tangent x. Okay, so that's how I know the integral of secant is equal to natural log absolute value secant theta plus tangent theta, and then plus c. However, the original integral was in terms of x. So now we actually have to replace this and say, all right, well, what is secant theta? So I'm going to erase the side quest now that we've conquered it. Yeah, this is why I think they took trig substitution out. It just takes forever to do these. Like these questions are like little marathons to get through. Okay, so now I just find each piece, and that's where the triangle comes in. Secant theta is, just think this is like 1 over cosine theta, which is the same thing as like the hypotenuse over adjacent. So I would have square root of 1 plus 9x squared like this, and then tangent theta is equal to 3x. So this is going to be natural log of absolute value square root of 1 plus 9x squared, and then plus 3x plus c. All right, I believe that's it. I have to, let me look that one up just to be certain. I don't want to lead you on a wild goose chase. I hope that's in the back of the book. Let's see. Moment of truth. Oh, that's I could always punch that in on Wolfram. Let's see. Wolfram, tell us, are we correct? So I'll say antiderivative of, and then we have 3 over 1 plus 9x squared to the 1/2 power. All right. Moment of truth. Oh, they use hyperbolic sine. We don't want that. Oh, yes, it's correct. Math works. All right. I feel victorious. That was satisfying. So it still works. Oh, anything you should relearn for calculus 3? I mean, I would say your limits and basic derivatives and basic integrals need to be sharp, because in calculus 3, they use a technique called partial derivatives and, integration with double and triple integrals, which is kind of like, it's calculus 3 was 13 years ago now. So yeah, it's kind of rusty. But if your techniques like chain rule and all that are like really, really sharp with you, Kenny, I know you know your stuff from last year. I would say, brushing up on the basics can't hurt. But because you have such a strong foundation in the basics, I think if you just, whatever you did last year, if you do the same thing in Calc 3, I'm confident you're going to be more than okay. It's a little bit more abstract because now you have to learn how to think in 3 dimensions. Not that you don't already know how to, but it's a little bit strange thinking with a z-axis as well. But when you get to partial derivatives, if you understand the chain rule really, really well, and you think about it in terms of parts, like it's not as bad. But I would say just make sure your basics are sharp, that you know how to do like your derivatives and chain rule. Kenny will be my child's math professor. Oh, I wouldn't put that past Kenny. If you wound up as a math professor one day, that would not be shocking. I would say that makes sense. So it has my vote too. So other questions, but Bilal, I hope that helped out. That was fun to explain that wacky question. Yeah, no, I'm happy to help, Kenny. Part of me wants to relearn Calc 3 so I can make videos on that. Oh, partial derivatives. All right, so you're like right in the mix. Yeah, it gets strange. Then you learn about like double, triple integrals, spherical coordinates. 70-71 on the packet of fun. All right, let's see. 70 and 71. Use the graph to answer questions about blah, blah, blah. Okay. All right, let's get that set up. So the graph here, let's see, it looks something like this. Like we have a graph and it's lines and half circles. Okay, 2 line segments and a half circle. So it's like, 1, 2, 3, 4, 5, 6. And it's like we're going up. It's going up like this. going down like this. I'll make that neater. And it doesn't say how high up it's going, but I guess that's not going to matter. And then the half circle goes like this. Let's try that again. All right, so something like that. And for question 70, they want f prime of 5, which is the slope of this tangent line. All right, this question is pretty good. So here, remember circles, x minus h squared plus y minus k squared is equal to r squared. So that's the equation of a circle with any center. So hk is your center, and the radius is r. So here, notice the center, which is not on the circle, but it's centered at 4, 0. So right away, I'm saying this is x minus 4 squared plus y minus 0 squared, or y squared, equals, and the radius is 2. So this is going to be equal to 4. And now, if we take a derivative of this, so the derivative of this equation, this is going to be 2 times x minus 4, and to the first power, you could do the chain rule here, but the derivative of the inside is 1. And then you're going to have plus 2y dy dx equals, and the derivative of 4 is 0. So now they want us to find, where am I again? F prime of 5. So for this one, let's just see. If what you need here is you need an x and a y, so I'm going to say side quest. So side quest, when x equals 5, if you plug into the equation here, you have 5 minus 4 squared plus y squared is equal to 4, which this tells you 1 plus y squared equals 4. However, this is a big moment here. Y squared equals 3. Just be careful. Y is actually going to equal negative root 3, because you see how we're in quadrant 4. So this is the point 5 comma negative root 3. So the task here is to find f prime of 5. So that means now we're going to plug in. We plug in the point 5 comma negative root 3. So x is 5. So you have 2 times 5 minus 4 plus 2 times negative root 3 dy dx equals 0. Moment of truth. I hope this works. All right. So this is 2 times 1, which is 2, minus 2 radical 3, and dy dx equals 0. And then if we just do the algebra, this is going to tell us dy dx is, notice like we just add this to the other side. You know what? I'll show it with all the steps. No point skipping steps if we showed this much work so far. So we have 2 equals 2 radical 3 dy dx, and then just divide by 2 radical 3. So I really hope that this is, I really hope that it's choice B, and it is. Yay, 70 is choice B. 1 over root 3. Okay, so this is 1 over root 3. All right, I hope that made sense. A lot going on there. There might be an easier way. There seems like there's an easier way, but that is a way to do it. That looks like a calculator question, the next one. At how many points? Oh, so that one, I would say stay tuned for mean value theorem, which is a, tomorrow in class kind of topic for those of you that have me in person. Okay. All right. So that one, I'll give you like an idea though to follow. The basic idea is for the mean value theorem, if you have f of x on AB and f is differentiable and continuous, so this is a requirement, then we would say there exists a value c between a and b such that the derivative at c, so the derivative at c equals the average rate of change. Right, that's why it's called the mean value theorem. Remember, average and mean mean the same thing. All right, so at some point, the slope of the tangent line, so this is the slope of the tangent line, matches the slope of the secant line. Okay, so at some point those match. So usually what you wind up doing is like you have some graph. This is not necessarily what it looks like, but the concept is like if I'm going from A to B, see, this is something that's like nice and smooth. And I want to say like, oh, where is the slope of the tangent line equal to this slope? It's probably somewhere like around here. And let me make that neater. You see how like this is the tangent line. And this one is the secant line. So what could happen though is that you have more than one answer if you have something that's like very wavy like this. Because you see, like, if I want to know how many times do I have a slope that matches that, you know, like you could have, let's say here, this could happen. Down here it could happen, you know, so like you can have situations where there's more than one answer, but the concept is you're looking for when the slope of the secant line, which is between 2 points on the function, has the same slope as one of the tangent lines, which touches the curve at 1 point. All right, that's the idea. 30. So scrolling on back. Let's see. Oof. Yeah, that one's mean. Sorry about that one. It's a nice question though, but it's like a little bit tough. This one, I want to go slow because if we don't, it's like such a pain to redo this. I really don't want to do this more than once. All right, so y equals, and here we have a sine of c times t plus b cosine of c times t. Log differentiation, yes. So I can do that. How do you solve for the sides of a triangle if they give you an angle and two sides? I could talk about that. So hello to everyone just coming in. But yes, those are next in the queue. So this one here, we want the second derivative. So dy dx equals, and this one, just know a, b, c are constants. So we'd have a times cosine of ct times c. The derivative of the inside is c. And then we'd have minus b sine of ct times the derivative of the inside is c. So if we clean this one up, it's ac cosine of ct minus bc sine of ct. So this is dy dx. Now the second derivative, we just got to be careful. We're essentially like just doing this again, except this time this is minus ac sine of ct times the derivative of ct is c. And then here, the derivative of sine is cosine. We're going to have minus bc cosine of ct times the derivative of the inside is c. And now this is minus ac squared sine of ct. And then we have minus bc squared cosine of ct. All right, now let's see that. It shows up. So ac squared. Let's see. Oh, I think I see the inspiration here. So this is like one of those weird substitution ones maybe. So if we factor out a, let me see if we factor out a minus c squared. See how they have that in common? We have a sine ct plus b cosine ct. And if we remember back to the beginning, a sine ct plus b cosine ct is the original y term. So that's why this is minus c squared. Why is that? Why does that not sound familiar though from like years prior? I feel like I've done these so many times that the answers should just like kind of jump out at me. But let's see. Question 30 is choice B. Yeah, so that's correct. Cool. So it's like an annoying substitution at the end. All right. I'm going to bounce around here. So solving for the side of a triangle, if you have an angle in two sides. Okay. So there's really two scenarios you could run into. So if you have two sides and an angle, right? So let me just see. How do you solve for the side of a triangle if they give you an angle and two sides? So it's either going to be, you're either going to have SAS, that's two sides and an angle, or such a bad word, I can't even spell it, so I'm going to spell it backwards. But when they give you side-side angle, that's a different story. So in this case, if I had like, I don't know, 7, 6, and this is like, let's say 40 degrees, then you use SAS, you use law of cosines. Okay, so law of cosines. And the way I remember law of cosines, that's a hard formula to remember. And I don't have any notes in front of me. I'm just like doing this off the cuff. Is you have a triangle like this. And then the lowercase letters are always opposite their respective capital letter. But this formula is a squared plus b squared minus 2ab, cosine of angle C, and that's equal to side C squared. The way I remember this is I look for a side angle side connection. So notice, like what I'm thinking about here is the messy side is, it's like we have like side A, angle C, and side B. So like these are the sides. And this is the angle, I'll just abbreviate. Okay, so I look for two sides and the angle between, and that's the messy side of the formula. So just using that in this first case, I'm just zoom out a little bit. What we would have here is that this missing side, let me put an X here. I could say that 7 squared plus 6 squared minus 7, I'm sorry, let me write, I'll write my 2 first, minus 2 times 7 times 6 times cosine of 40 degrees is equal to x squared. So then if we want to solve for x, just square root that entire mess. All right, and now let me open up the calculator here. Whoops. So calculator, open. Why is it hiding? Give me one. You know, I'm gonna give me a minute to get this thing up and running. So where is it hiding? Oh, here it is. Okay. So let me do. You know what? I think I might. Maybe I'll resize this for now. All right, give me 1 minute to like kind of do a little like surgery on this thing. All right, and then this one. You know what? Give me, yeah, I'm gonna add the calculator as a separate source so that it looks nice. All right. So let me add in share a window capture. All right, and then TI. Where's our TI? There it is. Okay. All right, so there's this. And if I, let me see if I resize this, is that, yeah, it's gonna affect things a little bit, but whatever. So here, and now I'll turn this back on. So we look back, like that's what we were typing in. Okay. And resize this a little bit. So we're writing in the square root of, and we have 7 squared plus 6 squared minus 2 times 7 times 6 times cosine of 40 degrees. Notice I am in degree mode. All right. Oh, hi to Nibin, or yeah, I think I'm saying that right, but hello, nice to have you. So 4.544. So this is x equals 4.544. And so that would be for that particular one. All right, so I'll turn that off now. All right, so that's yeah, how that would work out. Now, when you know two sides in an angle, SSA is a different story. All right, we call that the donkey theorem. And there's two possibilities in that case. Now, this one you got to know the law of sines. So this is like sine A over A equals sine B over B equals sine C over C. And this one I do have an old lesson. So I'm going to turn this off for a second because I want to find the law of sines. And ambiguous case, I believe it would be law of sines missing sides. Okay. Let me just see if this opens up. Yes, I'm really rummaging through. I like that the questions are so random and I have to be ready to talk about anything. But I think it'll definitely go smoother in the future as this grows in popularity if people send me their questions ahead of time. So let me just see if this is the one that'll do it. And it might be. I think I have a better one than that. Let me just find this here. PRV. No, that's. Oh, maybe this. One more try. Looks like. All right. Well, you know what? If I copy this and paste this. All right. So I'm just going to grab this question. This is an old one, but it'll do the trick. All right. And let me reshare my display. So a question like this. All right. And for something like this, if we draw this out, triangle JKL. So J is 63 degrees. So let's say this is J. K is 11 degrees. And then L is up here. And oh, this is actually angle. This is angle side angle. Yeah, you know what? I'm going to have to make one up myself. I'm just going to make a random one because I wanted to match the actual question. Sorry, I thought it was like, because I wanted to pick one that definitely works. So angle side. Let's say, I don't know, this is 40 degrees. This is like 8 and this is 7. So here's the law of sines. So when we know angle side, but I'm going to write it like this, you want to use law of sines. And the possibility is that there's no triangles, one triangle, or two triangles. So the way this works out is, let's say I just give random letters here, A, B, and C. Then we would know lowercase a is 7, lowercase b is equal to 8, and we know the measure of angle A is 40 degrees. So that means we would use these two. So I would say something like this, sine of 40 degrees over side A is 7 equals sine of angle B over, and then we would have lowercase b, which is equal to 8. So then we'd multiply both sides by 8, and this would give you sine of b equals 8 sine 40, and then over 7. Okay, so now from here, you do sine b, and let me add another page. So we get to this step, and then if we 8 sine 40 over 7. So let's see here. We got 8 sine 40 and then divide by 7. So there's your decimal. And if you do the sine inverse of this, it tells you 47.27 degrees. Okay. So the measure of angle B is 47.27 degrees. Now, how does this actually help us? Well, now that we know what measure of angle B is, so let's go back to this triangle, 47.27. So this is 47.27 degrees. Is that now we could find the length of the third side. Because you see how right now we have 40 plus 47.27. So if we do 180 minus the sum of those two angles is 87.27. And here we could do that by hand, but why not? We have a calculator. So 180 minus 87.27. You get 92.73. So 92.73 is that now we know the third angle, 92.73 degrees. And now I'm going to copy this. So we're going to copy this. And I'm going to drag it down here. So when you want to find the last side, so we want to find side C. That's over here. We want to find this. Now we could do this any way we want. We could use law of cosines even. And we could say, remember side angle side. So 8 and 7 have this angle between them. So we have 8 squared plus 7 squared minus 2 times 8 times 7 cosine of 92.73 degrees is equal to the third side squared, C squared. So we have this. And now C equals the square root of that whole mess. So I'm just going to do that on the side. Square root of 8 squared. Yeah, these questions take a while. Plus 7 squared. And then minus 16 times 7. And then we have cosine of 92.73. Okay. And that's going to tell us that C equals 10.88. However, there's something else to consider here, which makes this topic very tricky. And you see how we said that the measure of, we started by assuming what was in purple. But one possibility that you have to consider here is you have to consider the possibility that when you had 48.7, so we had, let me just draw this over here. So we had 40, not drawn to scale, 8 and 7. See how we solved first for the measure of angle B. We found the measure of angle B to be this. One thing that you should check is you should check to see that your answer, so ASTC, that maybe the 47.27 is a reference angle. So maybe we have a reference angle of 47.27. And if we're in quadrant 2, sine is positive there and well. Sine is positive there as well. So if we do 180 minus just 47.27, so I'm going to do that 180 minus. We have to also verify the possibility that the angle was 132.73. Okay, but the problem with that, why that's actually is this is possible, 132.73 degrees, is that if this angle is this, and then we do plus 40, so then we do 180 minus that, we have 7.27. So this angle here could be 7.27 degrees. But what would I do to double check is I would run that through the law of cosines. Except I would do 8 squared plus 7 squared minus, and then we would have cosine of this, 7.27. And see what we get. 7.27. And if you do that, then this would be 1.38. But now, just to be certain, to be like really, really sure, I would do this over sine 7.27. I would do like, 1.38 divided by sine of the angle, 7.27, just to see that they match the other answers. So I would just double check this here. So you get like 10.9. And then let me see if I do 8 over sine of 132.73. Yeah, we get about the same thing. So this is a second possibility here. So that's why those questions tend to make people very sad. But good question. Logarithmic differentiation was also requested here. What degree do I have? Oh, I was a math major. I finished my math major in 2011, way long ago. Systems of equations, elimination, struggling with the first step. Okay. Oh, wow. I like that we've had a lot of people sign in here. So thank you all for stopping by. Definitely got to take a second to thank the people that came by here. Logarithmic differentiation. Yikes, that's also a very involved topic, but it's a good topic. It does take quite some time. Let me see. AP Calculus Problems Book. Full, and let me just do logarithmic. So logarithmic. Oh wait, it's like going slow. Don't freeze. They need us. I'm talking to my book. I'm sorry. I think that means I need sleep eventually. All right, please don't crash. Well, this could crash as long as the rest doesn't crash. Oh, why is it not? Let's see. I'd have to look up an old lesson on that. Here, let me just type in logarithmic differentiation. Let's see if they just have random examples. Oh, yeah, like x to the x. That's a classic example. So it's more about technique. So if you use logarithmic differentiation when you have a variable exponent. So if you had to take the derivative of this, what you could do is you take the natural log of both sides of x to the x power, but now this you could say is natural log y equals x times natural log x. All right, I think I have a video on this. I vaguely remember, to self-promote my videos. I have a video where I go through a lot of these examples. So now at this step, we take the derivative with respect to x, and you're gonna have 1 over y dy dx equals, and here you do the product rule. So you have the derivative of x is 1 times natural log plus x times the derivative of natural log x is 1 over x. So now you have 1 over y dy dx equals ln x plus 1. And then multiply both sides by y. So this is like the basic idea of like every log differentiation question. Is like you start by taking the natural log of both sides, you bring the exponent down, and then you do your derivative with implicit differentiation. Like that's the steps. But now notice dy dx equals this. We have ln x plus 1 times y, but y originally was x to the x. So that is our derivative. Yeah, that's a classic example from, what I remember. So that's log differentiation. But I have a video where I have like way more examples if you need to see a few more. All right, systems of equations by elimination. All right, let me just make one up. If we had 2x plus 3x equals, 7. It's probably not going to be nice numbers because I'm making it up myself. And then let's say we had like negative 3x. Oh, what am I doing? I'm sorry. I should have put a y here. My bad. I'm making this up on the spot. So, and then let's say we have this equals, 6. Let's say. Hopefully the numbers aren't insane. So what's going through my head here? There's two things. I'm analyzing the x's, and I'm looking at like, all right, it's like 2 versus 3. So I'm like 2, 4, 6, 8, blah, 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 3, 6, 9, 12, blah, blah, blah. So right away, I'm like, all right, 6 is the match. And then when I look at the y's, I'm comparing 3 and 5. So I have like 3, 6, 9, 12, 15, blah, blah, blah. And then I have 5, 10, 15, 20, and it goes on and on. However, here they match at 15. So I always take the path of least resistance, and it looks like matching the x's is going to be easier. So if you're stuck on the first step, this is usually the first step. It's all like going on. It's all going on in your head. You list. So the first step I would be to, in your head, is to, or on paper, to list the multiples of each coefficient of x and y. Okay, so list the multiples of each coefficient of x and y. So the coefficient of x is 2 and negative 3, but I just list the multiples of 2 and 3. And then I list the multiples of y, the y coefficients 3 and 5. And then I identify the match. And 6 is the easiest one, in my opinion, to work with. So if I want to make 6, I'm going to multiply the top equation by 3. And the next tip I would give here, even though you said just step 1, is when you eliminate terms. So I would say make matching opposites. To eliminate terms. Okay, so this is really, really, really big. Make matching opposites when you want to eliminate terms. So this, I would multiply the bottom one by 2. Because what do we mean by matching opposites? Well, 3 times 2x is going to make 6x, and then 3 times 3y makes 9y, equals 3 times 7 is 21. And now on bottom here, 2 times negative 3x makes negative 6x, and then 2 times 5y makes 10y. Yeah, these numbers are going to be awful because I'm making it up myself, and then 2 times 6 is 12. So now when we add this, notice these cancel. You have 19y equals 33. So as awful as this looks, our y is equal to 33 over 19. Sorry if I said 19 over 33. 33 over 19. And now to solve for x, yikes, this is going to be painful. 2x plus 3y equals 7 is you just plug in here. So you have 2x plus 3 times 33 over 19 equals 7. And then you'd have 2x plus 99 over 19 equals 7. So x equals 7 minus 99 over 19 divided by 2, whatever that is. Yeah, something like that. But obviously the numbers are ridiculous because I made up the numbers myself. Usually if I have a lot of time. Do we not multiply the t as well? Wait a minute. Where's the... Wait, how long? That might have been a long time ago that I missed out on your question. My bad. I'm just trying to keep track here. But once again, thanks for the support to everybody here. So cool. I think 131 people stopped by in total. We have 12 people viewing right now. So this is definitely the best week yet. And I had some tech issues last week that I'm figured it out. My goal for, if not next week, the week after, is to figure out how to put comments live in the chat the most efficient way possible. There's an extension I got to get on Chrome. Oh, you got Y. Perfect. All right. So got that one. 7071. All right. So any other questions here? Where are we on time? Oh, 9:34. So I'm a little bit past, but math questions? Oh, Teddy Polk, I already answered. Thank you. But yes, I mentioned already that I was a math major. If I could redo college, I probably would have majored in like math and physics. I taught physics for 2 years at the high school level. For those of you who don't actually go to my high school, it was so much fun. It's like a really awesome subject. So if I could do things over, I probably would have majored in both. Because, it's just like a really interesting part of science. I mean, I liked all the science. I really liked physics and chemistry. I found to be most interesting. Not that I don't like biology. It's just I I appreciated the math aspect to chemistry and physics, whereas like biology for me was like more, like a little bit out of my scope of like what I don't want to say like, oh, I wasn't good at it, because if I had to really try, like you could be good at something, but I was just like more naturally interested in chemistry and physics, if I had to be honest here. But yeah, I have to advertise this there's like subreddits where people like need help with their homework and stuff. There's also like an AP calculus subreddit. So I got to try to get this to be more popular so that when the AP test rolls around, the last year, the day before the AP test, I had like 25,000-ish views. So I think that'd be so cool to have like over 1,000 people on the live stream at once. The live streaming is a lot of fun. So once again, thank you all for making it nice. So any other questions? Just checking out the chat here to see. All right. Well, we're 1 hour in. I'm going to say thank you all for swinging by, and we will be here next week as well. So, stop by next week, Wednesday at 8:30. I'm also going to try to make Saturday night, this time, the time for my chess live stream. So, 25. All right, maybe that'll be my parting question. But I'm going to try to make Saturday at 8:30 the time for chess live stream, because I had a lot of fun doing that last time, and we had a decent amount of people on there, most of them my former students. All right, so multiple choice practice. And let me see which 25. Oh, okay. So for 25, what you need for that is you need the formula for the second derivative of parametric equations, which is a Unit 9 topic. So let me just get this going here. So 25, let me just write the question down for one. This is a fun question to end with. All right. 25. Now, this one, we have x equals t squared minus 1. And we've got y equals, let me make this a little bit more spaced out. Y equals t to the 4th minus 2t to the 3rd. Now for this, the first derivative of a parametric dy dx is dy dt over dx dt. Now, the bear trap of the century, please don't ever, this, I'm going to write, is not equal to. Don't do the second derivative of y over the second derivative of x. All right, this is a common mistake. So don't do that. It's tempting to do that. I think almost everyone's natural instinct is to want to do that. But what you're actually doing is you're doing the chain rule here. The derivative with respect to x is the same thing as the derivative with respect to time times dt over dx. Okay, so that's what's going on here, that I want to take the derivative with respect to x of dy dx, which is dy dt over dx dt. However, the problem is d over dx doesn't match with this. So what we do is we do d over dt of dy dt over dx dt. But then we have to tack on this extra dt over dx, which this dt over dx is the same thing as 1 over dx dt. Okay, those are the same thing. So then this becomes d over dt, dy dt over dx dt. And if I send that down here, notice it's like dx dt squared. All right, so I believe, from what I remember, I forget formulas all the time, but I, remember how to derive certain formulas, this being one of them. So this is the formula we're going to attempt to use here. And I like that you're asking a question that's not expected of you. It shows that, You have the right idea about learning. So I'm just going to find this part here. dx dt is 2t. dy dt is 4t cubed minus 6t squared. All right, this is going to be my last question. So then first order of business is what we want is we're going to find the derivative of dy dt. So the derivative of dy dt with respect to time is 12t squared minus 12t. So now we have all the pieces. We want to know d squared y over dx. Hang on a second, let me fix that. Oh yeah, over dx squared. This is equal to 12t squared minus 12t over, and I just have to make sure I didn't make a silly mistake anywhere. dx dt squared is going to make 2t squared like this. So this is now 12t squared minus 12t over 4t squared. And where are we evaluating this? At t equals 1. All right, let's see. So this, wait a second, something got mixed up somewhere. Where was the missing piece? What am I? Give me 1 minute. It's somewhere. Oh, you know what it is? Wait. dy dx is dy dt over. Oh, wait. There it is. When we took it was this part here. Yeah, see, that's why this being a last question, I'm going to have to patch this up. I'm sorry if you were writing all that. Let me fix this. See, that's the thing. In calculus, the formula part, when I was proving it, I went a little too fast, is equal to the derivative of dy dx. And this, we're going to write d over dt of dy dx times dt over dx. This is the way to go. I believe this is going to get us to the answer. So then this becomes d over dt dy dx. I got to look up the formula again. Okay. So then dy dx, I'll find that first, is dy dt over dx dt. So let me try that out. See how that goes. 4t to the third minus 6t squared over 2t. And yeah, because I'm trying to do this without looking at any formulas. I mean, obviously, if I look up the formulas, it's like 100 times faster. But I prefer to like rethink my way through stuff. So that's this. And now let's see. So that's dy dx. But now the derivative of dy dx with respect to time. So this is d squared y over dx squared equals, and d over dt of dy dx is 4t minus 3 over dx dt was 2t. All right, here it is. So now the second derivative at t equals 1 would be 1/2. Yeah, that's how it was supposed to go. I'm sorry about that. Yeah, that was the reason why we couldn't do it the other way is like we kind of ignored the fact, or I ignored the fact that there was a quotient. But something was bugging me about how that looks. So this is your formula for second derivative of parametric equations. But that's unit 9, which is far away from what we're doing right now. All right, but that would have bugged me. I was not going to end this until that was figured out. Okay. So look, one of the themes for math, look, even me, I taught BC Calc now from 3 years. And if I don't practice something for a while, like I didn't practice this for like, let's say 5 months, this specific topic, like I have to brush up again to get sharp. You know, it's not like, oh, at any given moment, if I took like 2 years off, I would just take any math test and ace it. Like there's like being sharp, being good, and then there's like being so good that you're ready for the AP test. So if I had to personally take the AP test, like, yeah, if I took it tomorrow, I'm confident I would, get a 5 on it for Calc BC. But if I wanted to get like a perfect score, I have to go into like super nerd mode and like really just get very, 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 very sharp with every single unit all over again. So there's like an intense mode to prepare, but anyone who got really good at this, like if you take time off, you definitely start to get a little bit rusty. And that goes for anybody at any level. If you stop like preparing like you're going into a competition, this is true for athletes as well. You know, you start to lose that that sharpness. Okay, so just be mindful of that. That's just general math tips. Okay, but yeah. All right, well, that was a great question to end with. So thank you, Xiaolong, for that question. I always enjoy answering that question. It pops up like every year when we're talking packet questions. But all right, I'm going to sign out this time, but thanks again for everyone. Well, thanks again to everyone for stopping by. So let's see here.